My name is Reed Farnsworth and I'm a TA with the Fab Lab crew. In this video, we are going to go over how to 3D print with clay using the 3D PotterbotTutorial. Let's get started. In this video, we are going to go over how to print 3D objects using clay using the version 9 3D PotterbotTutorial. We are going to go over parts of the PotterbotTutorial, downloading the 3D slicing program, setting up the PotterbotTutorial, printing your object, as well as how to clean up. Parts of the 3D PotterbotTutorial include the on and off switch that will send a Wi-Fi signal that your computer will connect to, the extrusion motor head that slowly moves the Acme screw into the piston that will press the clay to extrude it. This is turned on by attaching this cord. There is the plastic tube that holds the clay that is mounted by this clamp, the main nozzle, and then the printing nozzle that attaches through a small screw. Next, there is the printing bed that is moved by the X, Y, and Z brackets. We also have the clamps that will hold your material that you will print on. This is a 3D Potter toolkit. It includes a variety of nozzles with different diameters for 3D printing different objects, the screw that attaches the nozzles to the main nozzle, the Allen wrench that will attach these screws to the extrusion motor head and main nozzle. First, turn on the PotterbotTutorial. You'll find the switch in the back, turn it on, and it will start sending out a Wi-Fi signal. Once you've turned on the PotterbotTutorial, go to your desktop and select the Wi-Fi network menu. You should see 3DP. Select it and enter the password 12345678. Press connect. Now go to your settings. Select network and internet and go to status. Go to properties and scroll down to see the IP addresses. You want to select IPv4 DNS servers, the second one, copy, and go to your web browser. Paste the IP address, press enter, and it will take you to the 3D PotterbotTutorial interface. A quick overview of the interface: you can disconnect and connect to the Wi-Fi here, and on the right, press emergency stop to immediately stop the PotterbotTutorial's operations. In the machine control panel, here's where you will home X, Y, and Z. You can home all when you start the PotterbotTutorial as well as individually home them. Using the X, Y, and Z brackets, you can manually jog the head movement here by millimeters, as well as see their head position in space and machine status. Here you can manually retract and extrude the Acme screw. In the G-code files panel, you can view your previously uploaded files, upload new files, and print them. Upload G-code files using your desktop, and view files here. Here's where you will also press to print. In print status, you can monitor your print and make changes and adjustments. Print control allows you to pause your print, stop your print, and print another model immediately. In extrusion factors, you can adjust the rate and amount of clay extruded from the nozzle. And speed factor changes how fast the PotterbotTutorial is moving. That's the basic overview of the interface. Now let's set up the PotterbotTutorial to print. In the interface, go to machine control and press home all. And the PotterbotTutorial is going to home its X, Y, and Z axes. After it's homed, go back to the interface. You're going to go to G-code files and print start location. Press yes. And the PotterbotTutorial is going to move its bed to where, when it is printing, it will start printing. We need to do this in order to load the clay tube and get it in the correct Z position for printing. After it's in its start location, take the material you're going to print on. Wood is a very good material for 3D printing. Attach your wood with clamps. Once the material is securely attached, we're going to make a shim. The shim is going to help us adjust the nozzle just above the material for successful 3D printing. So grab a piece of chipboard or folded thick paper and a caliper. You want your shim to be 1 to 2 millimeters. Place the shim on the printing bed. Grab your tube of clay and mount it in the bracket on top of the shim. Take the clamp and hook it on the right side. Adjust the clay on top of the shim and clamp it using the red lever, making sure it's secure. You can now remove the shim, making sure there's a gap between the material and the nozzle. Now we can attach this cord to the motor extruder head using the green plug. Find the slot under the motor extruder head and plug it in. Once it is plugged in, you can secure it using this Velcro strap. You'll know there is power when you see a red and green light on. Once you're set up, press Home Z to prime the PotterbotTutorial. Home Z is going to raise the nozzle up so it will have some room to extrude clay when it primes. After you Home Z, go to G-code files and press prime. Press yes. This is going to slowly turn the Acme screw into the piston in order to extrude clay. This process might take a while as the Acme screw turns very slowly. In this example, I have already primed the clay so it is extruding quickly. Once it starts extruding, press emergency stop to stop the clay. Remove the clay from the nozzle, making sure it is moist. Wipe the material with water. This will help the clay stick for its first layer. Now we are ready to print. Press Home All to get the PotterbotTutorial rehomed. Go to G-code files, select your file, and say yes. The PotterbotTutorial is going to move to its print start location. While it is getting into position, go to print status and extrusion factors and increase the extrusion factor. This is going to extrude more clay to get a more successful first layer and make sure the clay sticks. Watch the first layer really closely. It's going to warm up and start extruding, and as we increase that extrusion factor, we can see that the clay is sticking. Once you get a nice first layer, go back to extrusion factors. Lower the extrusion factor to 100% so it will extrude at a normal rate. Look closely at your print one more time. You want to be sure that the nozzle is not squishing the layer below it. If it is, decrease the extrusion factor. Once you've reached a consistent extrusion, continue to monitor your increase the extrusion factor. If it gets, you may want to decrease the speed factor as it will be more structurally sensitive. I'm going to time-lapse this print and finish up. Remove your print to dry. Be sure to clean up, especially to remove any excess clay from the wheels as well as the print bed. Run the print start location file one more time in G-code files to get the 3D clay PotterbotTutorial into a resting position. Find a piece of thick plastic and a rubber band and wrap the nozzle, keeping air out to keep the clay moist. Be sure to turn the PotterBot off. If the PotterBot is not going to be used for printing for a while, go ahead and unplug the cord from the motor extruder head, take the clay tube off of the PotterBot, and store it horizontally for another time. Now we are going to go over how to create your own 3D objects in Rhino, export them to Cura, and slice them for the 3D PotterBot. Here are some examples of some 3D printable objects for how to create a 3D object in Rhino and slice it. It's important to note that the 3D PotterBot operates in millimeters, so you want to double check that your Rhino is in millimeters. Solid 3D volumes. When your object is ready to go, select it. Go to File, Export Selected. You're going to save as an STL file. Give it a name, and press save. Press OK, OK, and now you're ready to open your object in Cura. If you haven't already, you're going to need to download Cura. Just Google search Cura and select the Ultimaker Cura website. Agree to continue browsing and make sure you're on the software tab, and press download for free and select the appropriate download for your computer. Open the file and follow the instructions to install Cura on your computer. To slice your STL file in Cura properly, you're going to need to download 3D printing settings from the PotterBot website. This will make it where it will automatically slice your 3D object to be printable on the PotterBot. Type in 3D Potter into a browser search bar to get to the 3D Potter website. Select 3D Potter Real Clay 3D Ceramic Printers. This is a useful website in general, and we're going to go to Info FAQ. The FAQ is a great hub to learn more about the PotterBot, the whole process, as well as troubleshooting info. But right now, we're going to click on the Cura shortcut and download the Cura setting link for Models 9 Wi-Fi. You're going to download the 3D Potter standard folder. So download the whole folder, and we'll open it in Cura. Alright, open Cura, and now we need to import the settings we just downloaded. So File, and navigate to the folder you just downloaded, and select 3D Potter Standard. Open as a project. Now, if you go to the Prepare View tab at the top, you can see that 3D Standard has been imported. Make sure it is selected. Here you'll see the 3D Potter settings, and these are going to be your automatic settings. Here you can look at different parameters such as your nozzle diameter, line width, and also adjust for custom settings. Now we can open our STL files for 3D printing. So navigate to your STL file that you saved from Rhino. Open it, and here it is in Cura. You can select it with the gumball to move objects, scale objects, and also rotate them. To slice your object, select it and press slice. You can preview it and see how the PotterBot will print it. So here we took a solid volume, and now it is going to print it at a 0.5 millimeter thickness into a vase-like object. So save it, and it's going to make your STL file a G-code file that the 3D PotterBot can read to print. Okay, those were the basics. We're really excited for you to 3D print with clay. So if you're interested, come to the Fab Lab and we will get you started. See you there.